Swayam Prabha. Digital India. Educated India.
Welcome to the NPTEL course on Building Energy Systems and Auditing. So, in the module 3, we are discussing about the building heat load estimation. In this fourth lecture of this module 3, the cooling load calculation part 2 will be discussed. In the previous discussion in the 13th lecture, we discussed about the how to take care of the periodic heat flow, how to variation of the two climatic data of a particular area, that the outdoor temperature and the solar radiation of some different surfaces can be taken into account. So, today we will see this periodic variation, but this periodic variation how can we normalize with the average data or so. So, we will look into that. We will see that how this variation is actually going to play in a total during a particular timeline. So, you see in the particularly in any place, this variation in the temperature is a periodic, even the variation in the solar radiation is periodic. Periodic means it is certain time. If you take, maybe if you take 12 hours time or if you take the 24 hours time for a particular day, it is not constant, it changes, it goes increasing, again sometimes it is decreasing, again it is increasing, something like that. But this periodic means this particular change will keep on repeating for maybe the next day or maybe the second half of the period or whatever. So, that is going to be a periodic function, but exactly that periodic function may not be because all the periodic function, if you see the simple harmonic motion or so, it will be either a sine function or maybe a cos function, but this change of this temperature, change of this the solar radiation for any kind of a surfaces are periodic. The today what is we see fluctuations, next day tomorrow we will see more or less the same fluctuations, but that is not going to be a purely sine or cosine function, that is number one. But that does not going to hamper our discussion, or that much of mathematical modeling may not will be required for our calculations or so. If we see that periodic function is applicable for a day, what is the change of the periodic function in the next day? It will be very, very minute. You may say that there is a change of periodic function from the summer month to the winter month. Yes, there is a change because of the angle of the solar altitude angle, the azimuth angle, that is going to change. The total solar hour will going to change. So, based on that there is a change. But if you take first, suppose today some maybe the 1st of January and the 2nd of January, there is not much of change. Even there is, we may say there is no change. If there is some kind of fluctuation in some kind of atmospheric changes in that particular locality, there may be a change definitely. But if you take the last 50 years data of the January 1 and the January to a particular location, and if you see that fluctuations are more or less the same. So, similarly we can say a particular set of data for a particular time period of maybe 1 month or so, it will remain almost the same, and then it will gradually shift to a little bit hotter maybe in the month of February. So, over a time period of data, we may say things are almost same, and that will ease our computation, and that will be follow for a big amount of data calculation like for annual calculation, right. So, let us go to some of the brief discussion about this particular changes. So, suppose I have 3 time line, maybe the 10 am, 11 am and the 12 pm in the morning. So, there are if you just go to the outside, there are 3 different temperature. Temperature is increasing from 20, 24 and 27 degree in this particular 3 time. There is a 4 degree change from 10 to 11, there is another 3 degree change into 11 to 12, right. There may be a change of I value, I this is the radiation. The radiation at 10 maybe it is 50 watt per meter square, radiation at 11 it is 120, it is high, and again maybe it is low at 80 at 12, maybe it is eastern side or maybe northern side. So, based on these 2 values, this blue dot and the yellow dot, we have 3 different values of the solar air temperature, we have different values of the temperature difference. So, at the end we have different values of the conductive and the radiative heat gain. So, we have seen in the last lecture or last discussion, yes, we have computed for all the 10 hours, this solar air temperature, the temperature difference del T and also the conductive and the radiative heat gain. Let us do the same for this particular 3 hours, and let us do these things for some other type of the more hours, maybe 12 hours, maybe 24 hours for a day. So, there will be some kind of a periodic changes or so, based on this 3 data we will going to change. Now, see, this is the nature of the suppose temperature variation or any kind of maybe the solar radiation variation also for a particular given period of time. See, this is periodic. The next day if you superimpose the data of the temperature data, it will be more or less same, and next day more or less same, and then gradually it will be change if the season changes or whatever. So, particular snapshot, let us say this is the variation. So, if I can find out the mean of the variation, so I may say that this is the mean line. That means, if I have mean of those data of 12 hours data, 24 hours data, this dotted line is the mean line. Now, this periodicity, that the periodic why this mean, where is the mean? This mean will be exactly at the center point of the all the data, where the amount of the higher data and the amount of the lower data from the mean almost will be equal or should be equal, because that is why that line is called mean. So, there are some observations will be seen or fluctuations will be above the mean, and there will be some observation will be below the mean. And because this is mean line, we may say that the sum of the mean deviation above mean deviation and the sum of the below mean deviation has to be equal, and that is why this is called the mean line, is not it. So, the amount of the above mean deviation, that means is this the green arrows, up arrows, plus if I add up, and the downward red arrows which is below mean, plus that means the sum up of those, this green will be equal to the red, because that is why this particular mean line has been developed, I mean by the all the data and adding all the data divide by a number of data. So, mean is developed based on that. So, if I see this mean calculation, if I only calculate based on this mean value, and I am not going to do 12 times or this 10 times or maybe 24 times periodic computation of all the data, instead of just take the mean. So, can I get the same effect? Let us see. Let us see whether I can get the same effect or not. So, this is called the periodicity of the mean. So, I have taken a simple area, I mean a particular window I have taken of area of 10 meters square. The U value of the window is 4, SHGC is 0.6, the absorption values are 0.5 and the conductance values of the surfaces is 20. And the first point what I have written is that the heat gain through the given window is computed based on the conduction and the radiation over this 5 hours. This serial number 1, 2, 3, 4, 5, the outdoor temperature are 20, 25, 30, 35 and 30, just I have taken some random number, and also I have taken the solar radiation for those 5 hours as 0, 50, 75, 100 and 75, just some random number. and I have 10 meter square of the window area, and those are the property values. So, I want to use this solar air temperature, calculate the solar air temperature for those 5 hours, calculate the conductive gain for those 5 hours and radiative gain for those 5 hours, and add up and see what is the effect, and let us see what is the effect for the mean way. So, here I have just like our lecture number 13, I have calculated the solar air temperature by this particular formula and using this data, and I got the variations, right. And I also have the indoor temperature, I think I have mentioned over here. I have mentioned that it is indoor temperature has to be, I am assuming it is 18 degree, I keep it at 18 degree, and I got the delta T for all the 5 hours. I got the area of this particular window is 10, U value is 4, SHGC is 0.6. So, the conductive heat gain from this equation, area multiplied by the U multiplied the delta T based on the solar air temperature and the T in indoor set point temperature. I also calculated the radiative heat gain from the area of the window, the SHGC of the window, and the I value, corresponding I value of those 5 hours. So, you see the first hour it is 0, conductive heat gain, why? Because the radiation I value is 0. Okay. The first hour as I value is 0, the temperature, outside temperature become the solar air temperature, because this I value is 0 in that case, right. So, I have calculated. After this calculation, what I did is that I have added up those values, those 5 hours values, and this is the, I think I have mentioned over here, no, sorry, I have added up these values. So, total conduction value is 2300, sorry. What is this 2300? Total heat gain conduction, total heat gain through conduction 2300 watt, and this yellow box indicates the average heat gain throughout this 5 hours. So, that is, this is average, this is average, this is total. So, how I got the average to total? This 460 multiplied by 5 hours gives me 2300. Similarly, the radiation average is 360, the average is 360, this is your average, which is your 360 watt multiplied by the 5 gives me the total, which is 1800 watt, right. So, this is the average and this is the total. Similarly, I have also found out how much is the average temperature, solar air the outdoor temperature 28 degree. What is the average solar radiation? 60. 28 degree is the average temperature. The average solar air radiation is 60, not 300, 60. Average solar air radiation is 60. Total is 300. Total is 300 for this 5 hours, 60 into 5. So, this is 60 into 5 is equal to your 300. Average solar air temperature is 29.5 and average del T is your 11.5. Okay. So, based on this 5 hours calculation, I found the average or mean value in the yellow boxes and the total values are in the green box. And now, see, if I use this average outdoor temperature, the average solar radiation, could I get the average TSA? Should I get the average delta T? Should I get the average heat gain? Should I get the average heat gain through radiation and the conduction? So, if I use 28 and 30 instead of all the 5, should I get 29.5, should I get 11.5, should I get 460 and 360, and after I get 460 and 360, I can just multiply with 5 and I can get the total. So, that is my ultimate aim. So, let us see. So, here is the same fundamental, and then see, I have first find out this average solar air temperature based on the average values of the outdoor temperature and the average value of the solar radiation. So, these values are your, you see the 28, why 28? This is your 28 average value. See, if you go back, this is 28 and this is 60. Please remember these two values. So, this is average value T O A bar and this is I bar is 60, and I got exactly 29.5 is the average solar air temperature. You see the average solar air temperature is 29.5. So, if I now find out the conductive heat gain, so the area is 10, 4 is my U value, the average TSA is 29.5 and my indoor set point temperature is 18 degree. By calculating, I got exactly 460. What is 460? Is the average heat gain through the through conduction, and if I multiply that into 5, I can get 2300 watt. Why 5? Because this average is based on 5 hours. Similarly, if I find out the radiation, the 10 is the area, 0.6 is the SHGC, 60 is the average I value, this is the average I value, and I get exactly 360, which is this, and if I can multiply that by 5, I will get 1800 is the total heat gain through the radiation. So, that means, instead of doing this whole business, I can actually, if I know this data, actually if I can calculate this average data, I will get the same result for the day for 5 hours, and if it is going to apply, if I apply it for 12 hours, if it apply for 24 hours, if I apply it for 1 month, it will be the same. Because periodicity is such a way, is we have seen, is the total amount of positives and the total amount of negatives are exactly, some of those are exactly equal. So, if I want to see the what is the total day load, total weekly load, total monthly load or annual load, I can exactly go with the average annual temperature and the radiation, average month wise radiation and temperature and all those kind of things. So, no need to go for the whole calculation what we did in the past lecture or so. Past lecture was definitely required to know that how things are going to be happened, but here we want to try to take a shortcut path, but that shortcut should not give me the inaccurate result. So, definitely I am getting a accurate result for a particular day, particular month or whatever, and annually I will not take the average, maybe only what I can do, I can take the average solar radiation maybe for the summer month or maybe the some other month or maybe the average solar radiation and the temperature data for each month or so, and that will be give me a tentatively very accurate kind of a result for annual heat load cooling load calculations also. So, as we have discussed, multiply by 5 will give the actual result also. So, we are very happy that now we can actually use some less amount of data and try to find out the actual impact of annually also. So, here I have taken a just hexagonal kind of a space, and the same the U value SHGC surface absorption I have taken. The building height is 6 meter and the north, east, west and south are of 12 meter of length, the wall length. So, that means the 12. So, those areas can be calculated, and the northeast, southeast, southwest and the northwest, those are the 10 meter length, because it is octagonal shape. So, there are 8 directions. So, those also will take some changes of the radiation and all those things will be taken care of. So, that is the 10 meter of length. So, the facade area can be calculated, assuming all the walls will have 15% of the WWR, indoor set point temperature is 24 degree, and suppose the building is located in Delhi, which is the 28.7 degree north latitude, and building works for, this is very important, building works for 20 days for a month and 8 hours of a day. And what I want to see, I want to actually project, estimate the annual load. So, what I need? I at least need the monthly average temperature, number 1, and the monthly average solar radiation of all the 9 sides. Why 9 sides? There are 8 octagon, 8 sides, and there is a roof horizontal. So, all the 9 sides facade, if I know the solar radiation data average per month. So, there are 12 such data for each side, and the 12 such average monthly temperature. So, based on that I can calculate the monthly requirement of the or monthly cooling load and adapt, and then finally annual cooling load. So, again I have used the Excel sheet. So, this particular data I am going to use. It is the NBC data. NBC part 2 volume 2 has given this data. So, it is for 9, 13, 14, 17, 21, 25 and 29 degree north latitude in our country, and all the 9 facade data are mentioned for the summer month and the winter month. Okay. So, Delhi will be in and around 29 degree, the Calcutta will be in and around 21 degree north. So, your city locations will be very close to, I mean you have to take the closest north and the data of that particular. So, if I see Delhi, suppose Delhi south wall will actually receive in the summer, I think first line is the summer, 1350 watt per meter square per day. So, that means, if I assume that is a 12 hours is the duration of the sun duration also. So, 1350 by 12 watt per meter square per hour will be this particular. The winter month will receive more in Delhi. See, this is the winter of Delhi, which is 4981 by 12 watt per meter, because I am assuming, this is my assumption, that 12 hours is the total radiation from something like that. I mean it may not be exactly 12 hours, it is also fluctuate in the summer month and the winter month, but let us assume this as 12 hours. So, these are the data I have taken. This is the first 21 degree north is for Kolkata, and this is for Delhi, and I have also taken down the Kolkata and the Delhi monthly average temperature, and I use this particular data. So, I know the north facade data, for facade area is 72 meter square, northeast, and those 4 walls are of 60 meter square, and the roof area I have calculated from this particular geometrical shape as 506 meter square. Of course, the roof is very high with compared to the other wall. U value, SHGC values are constant for all the facade, I mean for roof, wall and all this facade. Indoor temperature is 24, working days per month is not 24, it will be 20, I think, it will be 20 days. So, this is a typological error, this will be 20, and this will be the working hours per day is 8. So, I have calculated this thing in the Excel chart. So, this is that Excel chart. So, in that Excel chart you have length and height, just like the earlier one, the length and height and WWR for all the 9 facade. So, you just keep on changing, your building has different, you may have some area, some facade missing, maybe it is your square building at you have only the northeast, southeast and also do not put anything in the north and east and west and those facade. Give the wall data, material data. Table 2, if you can fill all this green one is you are actually filling the you have to fill, and this is also of course, this is partially white. So, I must give this as also as green. I am sorry, this has to be green. So, now you give the data of that particular latitude of north, that from your the NBC, north, northeast, south, southeast, summer month and the winter month, and I have assumed here 4 winter month and 8 summer month. The 4 winter months are November, December, January and February, and rest all are I have calculated in this particular Excel chart as the summer month, and this is the outdoor temperature. This is the Delhi data. This has to be 20, I have to change it. 20 is the working hours, and based on that you see your value changes. Or what is this first the chart per month in the x axis, the y axis is the building load kilowatt hour. So, for the month of January 3040 kilowatt hour will be the total load, cooling load, and this is only the envelope heat gain, not the internal heat gain. So, it is increasing and maybe highest at this particular point of the month of May in Delhi, and then gradually going down. So, this is the heat gain through different wall with different facade and all, and this is the roof is actually very high, because your roof area is also very high compared to those are 72 and 60 or something, and that was 500 something, 509. Definitely it will be very high, roof is exposed to, but all other surfaces are almost very similar. North is very less with compared to the other 8, the east is high, west is also very high in Delhi. So, we have to really take care of the east and west in Delhi. Of course, roof is always going to be the exposed. So, now if you change this data for some other cities, you have to change this data. So, from the NBC you take the nearest north latitude and put those values, and for your city you just check and give the monthly average temperature data. You can change the working days. Suppose yes, it is a hospital building. So, let us assume the working days as 30 in a Delhi and some it is 24 hours, it is hospital. So, see it is changing, it's a no change, or like that you any change. Suppose you want to give some treatment in the window, the last slide also have seen. So, some changes will be occur in the window data. You want to give some kind of a insulation in the roof. So, instead of 3 now you are maybe getting 1.25 or something, you see there will be some change. .25 or something will be some kind of a change, but probably this change is not occurring here. Maybe some I will check and I will see that there should be a kind of a maybe some mistake has been done. So, this particular things will going to change as per the change of data. So, let us go back to the PowerPoint presentation again. So, based on this I have calculated, and the peak hourly load and those final output I have calculated. I have this graph I have already shown, but only have to check that this roof is not changing based on the U value. So, I have to check that one, maybe there is some error. I have also calculated for the Calcutta based on the Calcutta data or the nearest Calcutta data for 21 degree north, and the peak loads and everything has been calculated. Similarly, with just change of the solar radiation data and the monthly temperature data for Calcutta. So, I have also computed this one, and I have compare the data of the Calcutta and Delhi, and you see the Delhi is the blue one and the Calcutta is the orange one. Delhi, the winter is really a, I mean the temperature, outdoor temperature is little less with compared to the Calcutta. So, as you see, you require bit more heat loading in the first 3 months till March. April both are same, but from April onwards Delhi is picking up, and May, June, July, August, September is Delhi is slightly high, but those 3-4 months of Delhi is really high. October both are same again, but November and December Delhi is less with compared to the. So, it is perfectly goes the way it is actually should be, and based on this NBC data and the temperature data I have calculated. So, this particular lecture takes you to the cooling load calculation. We have seen the mean is going well, mean temperature variation for a month, and the outdoor temperature data for average temperature data is going well, and this particular computation is based on the conductive and the radiative heat gain. Thank you very much.